assessing the model, which is the concept goodness of fits. So we may be asking, is the dependent variable well explained by the independent variables? So to answer this question, we need to go into the concept of sum of squares totals. So sum of squares total SST is the total variation in the dependent variable, which is the y, and it is consists of two parts: sum of squares regression SSR and also sum of squares error SSE. So SSR is the variation explained by the regression line. SSE is the variation not explained by the regression line. So when we up these two, variation explained by regression line, variation not explained by regression line, we will get the total variation in the dependent variable. Another important concept is the standard error of the estimate. So this is the formula for the standard error of estimate. So meaning that if you look at the value of S epsilon, so the smaller the value, the better the fit of the line to the data, meaning that the observed values Y are relatively close to the line. So meaning it gives us the best fitted line to the data. Then the concept of coefficient of determination, or we call it as the R squared. So R squared here, the formula is SSR over SST, or it is 1 minus SSE over SST. So it is simply the sum of squares regression over sum of squares total. And it measures the percentage of the total variation in Y explained by the regression line. So for R squared, it will be between 0 and 1. So if you have R squared equals to 1, but it's highly unlikely that you'll get equals to 1. But if it is 1, meaning that all the independent variables perfectly explain the variation in Y. Another concept is the adjusted coefficient of determination, which is the R squared, and then you have a bar symbol on top of this. So this is adjusted R squared. So adjusted R squared shows the proportion of variation in Y explained by the model, which has been adjusted to take into account the sample size and also the number of independent variables used. And it penalizes excessive use of unimportant X and useful when comparing models. So meaning that uh, the R squared value will increase as you increase the independent variables. So we do not want the value of R squared increases because of just the number of independent variables. We want the R squared increase because the axis does contribute to the explaining the variable of Y. So that's why we have the adjusted R squared penalizing the excessive use of unimportant or irrelevant X variables. And adjusted R squared can be negative, although R squared is a non-negative value, and the adjusted R squared is always going to be lower than R squared. The value of R squared, adjusted R squared, and the standard error of the estimate will be given in the estimation output. So this is the R squared 0.943, meaning that 94.3% variation in Y is explained by the model. So adjusted R squared is 0.93, meaning that 93% of variation in Y, which is per capita consumption of chicken, is explained by the model, is explained by all the variables x1, x2, x3, and x4, but taking into account the sample size and also the number of independent variables used. So this is an example of estimation output in the simple regression model. So you have the R squared, you have the adjusted R squared, and you have the standard error of estimates. So either way of using, whether you are using Excel or using eViews or using SPSS, you will be given straight away the information from the estimation output.